Hey guys, it's Danny here from Disrupt Tutoring, and as always it is a pleasure to join you. In this video we're going to do a question from the November 2018 Grade 12 Physical Sciences Paper 2. This question deals with a system in equilibrium represented by this balanced chemical equation. Dinitrogen tetroxide decomposes to nitrogen dioxide and reaches equilibrium at 325 degrees Celsius, where the final color of the gas is brown. The question tells us that the volume of the syringe is decreased while the temperature remains constant, and asks us to state how this will affect the number of moles of dinitrogen tetroxide, the value of the equilibrium constant, and the rate of the forward and reverse reactions. So to answer this question, you need to recall Le Chatelier's principle. If a system in equilibrium is disturbed, the equilibrium position will shift to oppose the disturbance and re-establish equilibrium. So for the first one, the number of moles of dinitrogen tetroxide, we can look at the number of moles in the balanced equation. If the volume of the syringe is decreased, the gas is compressed and the pressure is increased. So according to Le Chatelier's principle, the system will favor the reaction that opposes the disturbance. In this case, to decrease the pressure, the system will favor the reaction that decreases the number of moles of substance per unit volume. So in the balanced equation, there are 2 moles of product, but only 1 mole of reactant. And that means that the reverse reaction will be favored, and the number of moles of dinitrogen tetroxide will increase. For the second question, the value of the equilibrium constant, you need to recall that only a change in temperature can change the value of the equilibrium constant. So for an increase in pressure, with a constant temperature, the equilibrium constant remains the same. For the third one, the rate of the forward and reverse reactions, an increase in pressure will increase the concentration of the substances, and an increase in concentration will increase the number of effective collisions, thereby increasing the reaction rate of both the forward and the reverse reactions. So even though the reverse reaction is favored and will proceed faster than the forward reaction because of the increase in the number of moles per unit volume, both of the reaction rates will increase. Okay, so before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.